So I Will Survive is talking about what every living thing needs to survive. And especially because we're in anatomy and physiology class, we're going to talk about humans. There are 5 things every living thing needs to survive, and they're in no particular order on the PowerPoint. Food. Every living thing needs food. This is a python or an anaconda that just swallowed a gazelle. That's its tail sticking out of it. This was actually in a road in China. They had to get a forklift to move it. What do we need food for? Well, there are really two things we need food for. We need food for energy, and we need food to build us. And we'll talk about this later when we talk about nutrition, but you are what you eat. Okay, most of you think of using food for energy, but building materials is probably as important. Oxygen, why do we need oxygen? Well, we need oxygen to get energy from the food you eat. And when you eat food, you probably, I don't know if you ever thought about this, but the food you eat is no good to you, except for building materials, without oxygen. So we need oxygen. The third thing we need, and you've probably already thought of this, is water. Now, why do we need water? Well, water is one of those things that we're really not sure why it's so necessary. We know that you need to have this medium. We define it as a fluid medium for chemical reactions, a medium being a place it occurs. But to really say this is what water does for you is really hard to pin down. It's a solvent, right? It's solutions, right? So your body is this big giant solution of chemicals, and all these chemical reactions are going on inside. I mean, you are mostly water, between 50 and 70% most of the time. Okay, so water is really important. Heat. Cells can't survive without it. I put seawater above because if water freezes, of course, it expands, and when water expands, it would kill the cells. So if you've frozen a piece of fruit or something and then tried to eat it, it gets all mushy because all those cells have exploded. Your cells can't survive without heat. Okay, and I did try to find the corniest cartoons I could. Pressure is the 5th one. And you probably, when I ask kids to think of the 5, they can come up with food, water, oxygen. Some come up with heat. Pressure's the hard one to remember. If you didn't have pressure, we wouldn't be able to obtain things like oxygen. We couldn't breathe. That's probably the biggest reason. Lots of other reasons that we need pressure. So those are the 5 things all living things need to survive, and especially humans. Okay, now the next, we're kind of going to segue quickly into something else we're going to talk about the rest of the year. When we're talking about these things, everything needs to survive, we've really got to kind of couch that in, okay, so what do we do with these 5 things, right? Food, oxygen, water, heat, and pressure. The second thing is a phenomenon, homeostasis, that all living things do in one way or another. And homeostasis is defined as the ability of the body to maintain a stable internal environment. And if you take a minute to think about what this involves, okay, we're talking about things like body temperature is nearly the same. Your heart rate goes back to normal. Breathing rate, things like that. Chemistry of the body is pretty much always the same. So the ability of the body to maintain a stable internal environment. And I've written here, receptor to control center to effector. In other words, how does your body, quote, know that it's not stable? Well, something receives a signal, sends a message to a control center, which sends a message to something that changes the signal. For example, how does your body know you need more oxygen when you're running? Well, there must be something that senses you need more oxygen. That message goes to your brain, which tells your lungs to take in more oxygen. Right? I mean, that's the idea. So, there are 2 basic types of homeostasis. The first type is called negative feedback. Negative feedback works kind of like a thermostat in your house. Okay? The thermostat in your house is set at a temperature. If the temperature gets in the house gets too high, okay, if you have air conditioning, the air conditioning turns on and drops the temperature back down below whatever the set point is. Okay, if we're talking like my house where I don't have an air conditioner, what happens is in the winter, for example, the temperature gets too cold, furnace kicks on, heats up the house. When the temperature gets it high enough, the thermostat clicks, turns the furnace off, and the temperature starts to drop. And so on and so on and so on. And a graph of negative feedback looks something like this, where you have this normal, whatever, if you will. Okay, let's say we're talking about level of sugar in your blood. And you have this sort of up and down around this normal. Now, these peaks and valleys can be higher and lower, and it's not always uniform like this. That's called negative feedback. Okay, body temperature, heart rate, blood sugar are all examples of things that are controlled by negative feedback in you. The second kind then would be positive feedback. And positive feedback is quite a bit different. Rather than have this change around a normal, in positive feedback the response exaggerates or increases the activity. So one good example of that is contractions during childbirth. Okay? And whoops. I'll give you a graph of this first. And I'm going to graph it and talk about it at the same time. So during childbirth, fabulous drawing ability, pregnant, legs. Okay? Just a minute. As the baby, I'm going to draw the baby in here. As the baby's head pushes down, sends a message up to the brain. So as the baby grows inside the uterus, its head pushes on the opening to the uterus, called the cervix. That sends a message up to the brain. The brain sends a message down, a hormone called oxytocin, to the uterus to squeeze. And so the uterus might squeeze once every 3 hours at first. But as the baby pushes harder, so here's the baby upside down, here's the cervix. As the baby's head pushes harder on that, more of a message comes to the brain. More of a message to the brain equals more of a message to the uterus. More of a message to the uterus equals more contractions. So you get a graph that looks something like this. If this axis is strength of contraction and speed of contraction, and this axis is time, it looks something like this, where the response gets faster and faster and harder and harder and harder until it's done. And what is this time? This would be birth. So that's positive feedback homeostasis. And that is our discussion for the first unit.